Yes. Okay. Good.
This will be not gate automatically, and they are very easy.
And the opposite of input.
That's right. Whatever you give
opposite of input.
Exactly. And they are very easy to understand. So as I said, opposite of the input. So for you to say or gate, which is another gate, there are three. And or and not. So as I said. You can read about or gate the or gate. So this or output is at logic 1. Okay. When one or more are at logic 1. So that means with the OR gate, whether once you have one high at the input, automatically you have what? A high at the input.
One high at the input.
That's right. Only one high, whether A or B. If any of them is high, automatically you have high at the outputs.
Okay.
That's for the OR.
OR gate. Okay.
But
for the AND, both must be high.
That's right. Yes. So is it output is
let's say AND but lower. Output is low.
And you say AND this is the AND. Once you have bakuye high, now bakuye lower, automatically it's low because look at the switching arrangement. It's a simple diagram. I think once any high, not being here low, there's no way a current between a flow. So that's it. Once a current in
say low.
That's right.
Being a supply.
That's right.
And it's a being low, I ain't to me supply.
Ain't to me supply. And I ain't see low, I don't see to me supply. Unless it tuning in high. That's not about which my supply.
Okay.
Until we call it series circuit. So the AND gate is like a series circuit.
Okay. Series now or series now.
Exactly. So once one gate open there's no way a current between my heading flow into me flow that. That means you have low until say all the two are close. So that's why we have A and B down here. Last one we say A and B near 1 that's why we have 1.
Okay. If I show numbers no arranging is 0 0 0 1 1 0 1 1. That arrangement,
Yeah.
How do you get that concept? Like I don't understand how that arrangement. It must always remain that way.
That's right.
It always say one step, and not just say you understand what you are doing.
Obit make step, but anyway, in the exams, obit man trick come outside trickish way. Obit man make step amount until we a chew and poor person there, you fail. But I say, because you see, I know which me the 1 1 I better talk. I say, you'll be confused. What is 1 1? You'll be confused because why chew and poor? But you don't need to do that chew and poor thing. You're supposed to understand.
Okay.
Once I also understand any basics needed. Anyhow, about twisted question, you should be able to answer because you understand the core. You understand? Yeah. Because we say during my school time, say, we say input in but into why you will not be able to answer. And I see so much changing input number 3 number A B C.
Okay.
It means also when A B C automatically say all of them supposed to be high before you can get high. Because all name switching arrangement. See everything, if you're able to grab the switching arrangement, it will be very logic. Combining in amount, you'll be able to do it. So that's it.
Even 4, 5, 6 input class on
even your amount 100 can put different. I mean, I'm talking about different logics. If you say we're with my connecting into series, the answer with 1 will give you 1. So if that one is going through another circuit, which is not gate, automatically it's going to be the inverse of the output. I don't know what it is, but we say 1 1 will give you 1. Okay. So connect logic way at the another gate, which is not gate. Once not gate is receiving 1, what do you think the output will be? I mean, draw not this one, okay, is connected to a NOT gate, okay, which is who's our colleagues need to join it. Welcome, guys.
The master take anything.
Yeah.
Okay.
If I say supply 1 1 Emma way out, how 1? Now Emma will say so 1. What do you think the output will be?
That will be 0.
Exactly, that would be 0 because it's taking what? 1 over here. Here will be 1. So once this side will be 1, you will get 0 here. So you see the trick. So if you concept now the flow now see or the man combining logics in amount, you will still be able to do it. You see how when you're 0 until you say you follow some steps now. Okay. Oh.
I think that your colleagues will be joining.
I won't say be joining.
We can start from.
So until me try highlight maybe a confusion one. That's what I'm trying to do. So if any of them is guys, you are welcome. You can even ask anything that you think we should be able to. Yeah. To me, during time, they only pick you say grab this description, then they will go by the description. So I say, you will be a description now. Then obviously you go by the description and just write the exams and go. That is when ABI you start looking for the situation arrangement, and you have to understand the basic concept of this circuit. Just positive going up, negative coming down, connected to what LED and ABI indicator. Then you have your situation. This is the input. The A and B are the input. Okay. So we always go by. So just have it at the back of your mind that all the gates is just 3. We have the AND, OR, and NOT. These are the 3 basic gates that we have, or logic that we have. I always call it gate because of my background in my friend gate. So that's it.
Okay. So the main thing is for me to get the NOT, AND, and OR.
Grab this one. You understand this. Once you have
the rest is an inverse of those 3.
Yes, the rest are a combination. We call it combination.
Combination, okay.
Yeah. So this one. So these are the main 3 that you're supposed to grab. If you're able to understand the NOT, AND, and OR, okay, then the rest will be the combination. Because this, if you can check very well, you see that there's one circle here, right? Meaning that they've connected NOT to AND to give you NAND. So they are combining this and this. Okay, they're combining AND and NOT to give you AND, and you understand? And they are combining what OR and NOT to give you what NOR. OR and NOT giving you what NOR. So first thing first, you're supposed to know that okay, NOT is inversing. Like NOT will just take the value and just reverse it for you. If you give it 1, it gives you 0. If it gives you 0, it gives you 1. You understand? So let's say you want, so I have AND gate here or AND logic here, okay? And I want to convert this AND logic to what NAND. Of course, I need to put the NOT at the back of it.
Not today.
Yes. Okay. So whatever input you give it, you just reverse it. That's all. Just reverse so you reverse this one to be 1. You reverse this one to 1 because there's. You see, you've added NOT, okay? Okay. Then you reverse this one to what? 0. So you have 1 1 1 0. And when you check the NAND, it's 1 1 1 0. Without even looking at the table, you're able to get it here because you understand that okay, once I have my NOT at the back of my NAND, AND, every output of the AND will be what? Inverse. And that inverse is equal to what I have over here. As what? AND. As what? NAND. Okay. Yes, so it's better you grab the NOT, grab the AND, grab the OR. You understand? Yeah. So when you look at what I have here now, just look at this one like AND. And I've given you this situation arrangement, which is going to be very easy for you to understand. Okay, this situation arrangement over here. Okay. But that is how I was able to grab it when I was doing this. I have a situation arrangement that I know, okay, once you give me 0 0, I'll just come here. Okay, over here is 0. Over here is 0. Automatically, the bulb will not come out. I mean, the LED will not indicate anything because it's 0, 0, right? Okay, once I close B and leave A, of course, the same thing. Current cannot flow because there's a break over here.
Okay.
Current cannot flow because there's a break over there. So that's why you have what? 0 and 1. Now, if I take off this, let me erase. Take off this, okay? Okay. And let's say we close this one and have this one open, which is what? 1, 0. You understand? Because once you close this one, it's 1, 0. So it's what? 1 and 0. Automatically, it will not reach here. There's a break. So we go to 0.
There's a break. Yeah.
Yes, there's a break, right? So now let's have 1, 1, which is what? Close and close. Automatically, you have 1. You understand?
Of course. Yeah.
Yeah. So that is the context. So if you're able to get the situation arrangement, it will be very easy for you to do anything with it. You understand? It is very easy for you to do anything with it. Yeah.
Wow.
So if you want to, if you want us to continue, let's go by the next one. I think we can come back. Guys, you can ask any question. You can ask any question that you think it disturbs me. If I will be able to answer, I will answer for you. Okay. Let me clear this guy. Okay. So look at the OR. See the switching arrangement of OR. You could see that it's series, right? And at the same time, parallel. The switching arrangement is parallel, but connected in series with a circuit. You see the trick?
Okay.
You see the trick? Now, so let's try and put these tables and see how we will be able to overcome this. So let's say what? We have 0, 0. So let's say A is what? 0. And B is 0. Automatically, we hope you have 0. Because there's no flow. There's no way we can get, yeah, there's no flow, right? Okay, so now let's go to the next question, which was 0, 1. That means what? A is what? 0. And B is what?
A is 0, B is 1.
Once B becomes 1, it's closed, right? So it will flow down there to go through down, and you have your light out. That means we have 1. You see the trick?
Yeah.
Yeah. So that is giving you 1 over here, because B is what? 1. So once positive charge goes through the B, because it's closed, it will go through the bulb, and the negative is always there. So you have what? Output to be what? 1. So this one is solved. So the next one will be opposite, okay? This one will be what? 1. And then the B will be what? 0. Okay? So once the B is 0, the positive charge will go through the A, and you will still have your what? Light. So over here is what? It's correct. We have what? We have 1. Now, the next question is 1, 1, right? The next question is 1, 1. All right? So once we have 1, which is A, which is close, and we have B, which is what? Also close. Automatically, we have what? We have 1. Because some of the current will pass through this one, some of the current will pass through the top, and we have our light out. You understand? That's why we have what? 1 down there. Okay. So if you're able to grab the switching arrangement, okay, if you're able to grab the switching arrangement, of course, you understand everything. No matter how he treats the question, you should be able to do it. So first thing first, get the diagram, get the symbols ready. I hope everybody is aware of the symbols. You know how it is. You know how, at least pick a pen and paper and just draw them, right? The symbols, because automatically most of the questions will be coming from the symbol. Okay, we just draw something like this and just put something and say, okay, what is this gate? You should be able to identify all the gates. That should be the basic thing. You should be able to identify the gate. Okay, then the concept of the knot is easy, so you can grab that one immediately. Concept of the knot. Okay, one is easy. From there, then you come to AND. If we're a book type, you can just grab this concept. For a book type, just grab this concept that output logic 1, which is high. Okay, when and only when all 8 input, that means all the A and B. Okay, all 8 input, which is the A and B, are at logic 1. So the only way you can get higher at the output of the AND gate is when A and B is high, because it's a series of. You understand? Because it's a series circuit, so there's no way you can get higher output until you have what? 1-1. So if you're a book type, you can just chill it that way. The AND gate is a series circuit which accepts high before you can get high. Other than that, it's low. Apart from high, everything is low. You understand?
Yeah.
So if you're able to grab it this way, I think you can go. Okay. If any of your friends have any question or they want me to repeat anything, they can just let me know.
Okay, guys.
Can you hear me, guys?
Yeah, sure.
Okay. So if you have any question, so far, I don't know if you have any question, just let me know. And if you have any confusion, if there's a part that you don't understand too, let me know so that we can just, but I want you to get the call. Once you have the call, that's it. You should be able to do anything. Have you ever been to, or I think nowadays, I think we even have it in your homes. When you go to most of the hotels, you know, entrance, you have a switch over there at your door entrance. There's a switch, okay? You can flip it and it's on. When you get to your bed and you want to off it, you don't need to go to that switch, right? But you can switch it off from your bed. Have you seen that thing
from
before?
Your bed?
Yeah. That is what we call this SO. They're using this logic, SO.
Oh, okay. XO, right?
That's right.
Oh, okay.
Yeah. So logic is everywhere. You can apply it everywhere. It's a matter of understanding how it goes. You understand?
So even when the main switch is off, you can still on it at.
Yeah, because it's speaking. Unless I show you the switching arrangement of before you understand. Look at the switching arrangement of this one. Let me clear my screen. Anyway, don't let us go there. Other than that, I think we will lose focus. So why don't we start from top? Guys, is there any question? If you have any question, just let me know. I don't have a full version of this, my Zoom, right? So it will go up the next 10 minutes, then you have to reconnect it again, okay?
All right.
It will go off the next 10 minutes and you reconnect because I don't have the license for the full version. I'm thinking of getting it. I don't know. All right. So please, do you have any issue with any of these? I hope everyone can identify any of the logics, any of the gate. If you have any difficulties identifying them, let me know so that I can see if I can use a different technique for you to just recognize. Okay, once you see this one without a name, you should be able to know. Once you see this one without a name, you should be able to know. Any of you having any difficulties?
Boss, can you go over any technique? You know, we would just like to add it to what we already know.
Okay. So all right. So what I think I was saying something before you came. I don't know if you came in earlier on, but the gates are just 3. Okay. I call it gate because of my background. Okay. They are just 3. Okay. This logic, they are 3, which is what? NOT gate, AND gate, and OR gate. So look at the AND gate and then look at the OR gate. Yeah, you could see that there's nothing at the back of the tail. Right? Look at the tail. Yeah, you can mute yourself if you want to talk. You can mute yourself, right? Yeah. So guys, look at this one. Look at this one. You see? So this is pointing to this.
They teach me, I know.
Right?
They like that. Say you know past lecture.
And this one to have.
That kind of ask me.
I think I need to use them. Right?
Okay. I think you know what the lecture is teach. That can't say I lie. I don't go to class. So make I can't tell you that I don't go. I'm gonna tell you that no.
Yo, George.
The
you know, say you know, just
I mean, where you you know the club.
The guy keep muting body also.
Yes, mute yourself. Yes, I think I can. Yes. I think it's clear now. So one guy asked a question. I did not check your face. I did not even check your name. Sorry. So this is a trick. Okay. Just have it at the back of your mind that we have only the three, which is what? NOT gate, AND gate, and OR gate. This is the three basic gates that we have. Okay. The rest are combination. Right. When I say combination, that means if you want to get to know NAND gate, it's a combination of what? NOT and what? AND. Right. And if you want to know if you want to understand NOR gate, it's a combination of what? OR and what? NOT. You see the trick. So the most important thing is to grab the first three, which is the NOT gate, AND gate, OR gate, right? Once you have these three at the back of your mind, okay, I want to get to know NAND gate. Then you take AND gate and just connect your what? NOT gate to it, and that's it. Once you connect your NOT gate to it, that's it. You have your what? So this little thing over here, this circle at the back of the NAND gate, representing the NOT. Then okay, this is inverse. Whatever I receive from AND gate, I have to convert it. That's the meaning, right? The meaning is whatever I receive from AND gate, since I have this circle at the back of it, all right? Since I have this thing, I need to invert, I need to reverse it. If it is 1, I make it 2. If it is 2, I make it 1. That's it. The same thing applies to OR gate. Once you have this at the back of OR gate, it tends to what? NOR, meaning that whatever I receive from OR gate will be the inverse. That's why we have what? 0, 1, 1, 1 over here. But when you come here, it will tend to what? 1, 0, 0, 0. You understand? So it's inverse. It's the opposite. Okay? That means you take the output of it and reverse it because we have that NOT at the back of it. The same thing, you have NOT at the back of the NAND. So whatever you receive from AND, you reverse it. You make it 1, 1, 0 instead of 0, 0, 0, 1. Just inverse. I don't know. So this is how I was able to grab it, and then I was able to move on with it. So I don't know. Other than that, you need to go by this. You need to do the chew and pour style. If you don't want the chew and pour style, then after identifying, then you understand the switching arrangement. This is the switching arrangement. This is a basic circuit that everyone can understand, right? This is the basic circuit everyone can understand. So you look at the switching arrangement for AND gates, okay, and see switching arrangement for OR gate. Then we will look at another switching arrangement for NAND gate, then the almighty NOR gate, then SOR and SNOR. You understand? Okay. So I hope this will help you. The one who asked the question, I did not check your name. I'm not in the studio, so I don't have another second screen.
Yeah, it helped. It helped. Thanks a lot.
All right. So if you have any other challenge too, let me know. If any of you have any other challenge as to how to understand the concept, so that we can move on. Is everything all right?
Please, what about the exclusive OR and then exclusive NOR?
Okay, the SOR and SNOR. Okay. So the SNOR and SOR too, we can go, let's read SOR and SNOR. So you can read it from here, right? The output is at logic 1. When 1 and only one of its input is at logic 1. That means before you can get higher at the output, that means one of it is supposed to be what? One of these is supposed to be what? Higher, before you can get an output of high. So when you look at the switching arrangement of it is, when you have, let me allow this guy, okay. So when you look at the switching arrangement of the SOR, okay, look at it. Once you connect the switch to this and this 0, 0, of course, it's not going to give you anything. Once you connect it to 1, 1, it will not give you anything until you have 1 at the top and hot 0 at the bottom. So look at it very well. 0, 0 will give you 0. 1, 1 will give you what? 0. Until you have an opposite. So A is supposed to be 0, B is supposed to be 1 before you can get what? 1. And at the same time, A is supposed to be 1, B is supposed to be 0 before you can get 1. So you see, it's the inverse. So one of the inputs supposed to be 1 before you can get what? 1 at the output. So if you can grab this concept, okay, that this is what the output is at logic 1. When one and only 1 of its inputs is at logic 1. Otherwise, is at logic 0. You see the trick? Because when you look at the diagram very well, of course, when you move this switch up here, when you move this is a switch. I'm not ready to talk. When you move this switch up here, that means it's going to be what? 0, 0. Of course, 0, 0, you will not get your output. You will not get what you want, of course. When you say 0, 0, that means there's no negative charge coming through this. So this bulb will not hot light. Okay, when you give it 0, 0. But when you give it 1, 1 as well, of course, that means you're not getting negative charge. If you're not getting negative charge, of course, your bulb will not light. So the only thing is to connect 1 to 0 and 1 to what? 1. Then you can have what? A positive and negative charge coming through this bulb. You understand? The same way, when you connect it to 1 down there and connect the same thing to up 0, that means you have what? A negative charge and a positive charge, meaning your light can come up. So using the switching arrangement will be very easy for you to understand. So that's why we have 0, 0, 0, 0, 1, 1, 1, 0 will give you 1, then 1, 1 will give you 0. Because when you say 1, 1, of course, you don't have a negative charge. When you say 0, 0, of course, you don't have a positive charge to light up your bulb. But when you have 1 positive and 1 negative, automatically, you have what? Your bulb coming up. Have I answered your question? Is it okay?
That's okay.
Okay. A minute, the Zoom will just cut and I'll connect and you have to reconnect back, please. Okay. So when you see the S no is opposite of the S.
Examples on like some real world practical, so as we can like some systems that makes use of these gates.
Okay, so all these gates are in your memories. It's in our computer memories because something T triggers. You see registers and tree triggers and all that. All these logics are there. Okay, and I think I don't know if you were here earlier when I was explaining something to other colleagues that okay, most of the hotels when you go there at the entrance or where the door is, you can flip your light on. When you get to the bed and you want to off the light, you don't go back to that switch again, but there's a switch on top of your bed that you can flip it off. I think you've noticed that. Okay, so this is the basic. This is how the XOR is the work of the XOR. This is where we can apply that kind of logic. Okay. XOR. Okay. When you go deeper, I'm not sure in computer science we don't go much deeper. You only get to the registry and then we will come back. But when you're doing something like electronics, you build this yourself. Like you have it physical diagram. I mean a schematic diagram of these logic gates, and you build them and present before you can get your pass mark. Okay. So you understand how it flows. You understand? But when you open most of the memories, all these things are in the memories, our computer memories, our microchips, our microcontrollers, all of these things are inside, okay? And some of them too are like just, you can just program them. You can just write a computer program for them and they will function like the way you want. You know, everything is changing. So we are not doing things the way we used to do them again. We're not going to have a very bigger ICs and all these chips on your motherboard anymore. Now they are micro and they are small. Some of them accept a program, I mean a computer language to function. You understand? So if you're asking of where can I apply this, I can only tell you that it's in most of the chips, memory, microcontrollers, and all the microprocessors. All of them have all this kind of logic thing.
Okay.
I hope it makes sense. Yeah.
Right. Thank you. Yes, sir.
Yeah. So once you're doing your computer science program, of course, you need to get the concept and pass through. When you are out and you want to go deeper, or yes, you want to dive deeper into some things like this, and maybe you have to do microtech. Yeah, something like microtech, and then I don't know.
Okay.
Yes, but I know most of.
So then, can I cite a laptop as an example where you can manually switch it on or go through the software system? Does it also use exclusive OR?
You said what, your laptop?
Yeah,
I don't get it.
You can switch it off using the button, and you can also go to the software system like the Windows to off it. Is it also using the exclusive OR?
I don't know how to answer this one. Like when you touch your laptop button, your computer goes off.
Yeah, the power button.
Okay.
Power button.
Yeah, it depends. You know, when you touch your power button, of course, you are supplying some kind of a voltage to a certain logic. I don't know what it is, but it's one of them. Once you touch a button, something happens. Okay, so either you are sending a negative voltage to something, or you're sending a positive voltage to another thing. So once it's a programmable thing. Okay, once you receive a negative charge or once you receive 1, I want you to do this. It will happen. So you can, same way you can say, okay, once you receive 0, I want you to use that 0 to do this. So it depends on what the developer, the one who is programming the whole thing. So this question will, I think it will be very good to understand. It goes with microcontroller. I don't know if you've played with microcontroller. I don't know. It's not in your curriculum at this stage. You will not do microcontroller. You don't do microcontroller, but it's something like that. You're supplying once you start that button, you're supplying some kind of voltage to a certain logic. It's the same thing. It's one of the logics that we're using. But you know, there are combinations. You can't just pick one logic like this and just use it to do something. You understand?
Yes.
I don't know if there will be let me see if I can get something from the internet from you. Sorry about this. This is something different I'm doing. Let's see. I don't know if they'll give you a combination of some of this logic gates and they'll ask you to look for the output or something like that. Okay. Oh, I need something like this. This will not be easy. Okay. So guys, can you see this? I think I need to download this so that it will be very easy for us, right? You can see my screen, right?
Yes, you can see.
Okay, so let's say we give you something like this. Will you be able to like solve this? If it comes in your question that solve this, get me what's going to be the output if I supply 0, 0. If over here 0, 0, 0, 0, 0, 0, will you be able to go through this? Is it possible, right?
Yeah. But it will take a lot of time.
Yeah, it doesn't matter. It doesn't matter. It should take a lot of time. At least you need to analyze it very well. But at least if you want to go through one by one, which gate is this one?
Now gates.
SO, right? That's right.
SO.
That's right. That's SO. So what is SO saying? When you give 0, 0 to SO, what happened?
You get 1.
Are you sure? So we can go and
check. 0.
0, of course. So SO takes 1, 1, 0 and 0, 0 as 0, right? So now we have 0 at the back of. Sorry, you said someone said something.
I'm saying the Y is 1.
Okay, so we have 0 here, right? Okay.
Yes.
Okay, and if not receive 0, what happened? Because in here is 0, we have 0 here.
It becomes 1.
Okay, it becomes 1. Becomes 1. So once we have, that's right, we have 0 here and we have 0 here. So over here we have what? 1, right? Okay, now we come back to this guy. This guy too have 0, 0. All right. So what will be the output over here?
1.
1, exactly. So we have 1 here and we have 0 here, right? Okay, so this guy, which one is this guy? Which gate is this?
Not all.
That's what?
Not all.
No gate.
No gate.
It's not, right?
That's no.
Okay.
So what's the principle for NOR gate? Do you remember? No. Should we go back to the diagram and check?
The negation of all.
You said something I did not get. This is no.
Complement of all.
Should we go back to the diagram? The slides or something like that.
To find the NOR gate is the negation of the all values.
That's right. So I don't know if you can grab what I'm trying to. Okay, so we have no, right? What is no? So read about no. What's no say?
So output is at logic 0.
When one or
When
more.
one or more of bit 8 are at logic 1.
That's right.
All the inputs are at logic 0, the output at logic.
So it said output is at logic 0 when one or more input are at logic. So anytime you have 1, it gives you 0, right? Okay. So anytime you have 1, you have 0.
Hello.
Yes. Hello, I can hear you. I need an answer for this one. I need an answer for this one.
It's zero.
It's 0, right? Because anytime there's 1.
There's 0.
Okay. So we can put our 0 there. All right. So now at the top, we need to solve this guy. This guy is taking what? 0, 1, 0. So we have 0, 1, and 0. Going through, which gate is this one? It's an AND gate, right?
And
And
An AND gate is a series. So once we have even 0, automatically we should know the output. What will be the output?
0.
It's 0 because what? Because there's a circuit break. Because we have 0 here and we have 0 here. So of course this one will not do anything. So automatically it's 0. Nice one. I think you guys don't have any.
0.
Yeah, it's 0 here. Okay, so now we have 0, 0 going through what? NAND gate, right?
yeah, NAND.
So we have 0, 0 going through NAND gate. So what will be the output?
0. 1.
Explain why. Why 1? Why 0? Can you explain why 1? Why 0?
Yeah, the AND gates, the NAND gates are an opposite of AND. So if 0 gives 1, then the negative will be 0.
The negative will give what?
0.
Exactly. So we have 0. So if you're able to analyze this thing, then trust me, you are good. If you're able to analyze this and you're able to get this answer.
Hello.
I can hear you.
Yeah, is there an easier way to know the output for each one without having to memorize the table?
No, you don't need to memorize it. I mean, I don't have the memorization. I don't want to memorize the table. Don't memorize the table. You will not get the call. That's why I said you don't need to memorize the table.
What's the trick?
You said?
What's the trick? Because let's say you have 0, 0 through NAND gates. How do you tell the output?
Okay. For me, I have it at the back of my mind that anytime you give 1 to NOT gate, it gives you the opposite. So I don't need to struggle myself thinking about NOT gate, right?
Okay.
Good.
Okay.
Good. So I think I showed you earlier on. I showed you my diagram here, right? All of them has a switching arrangement. Okay. And you need to put only the 3 gates into your head. Now you're able to solve NOT gate. So NOT gate is what? Already solved. Now we have what? We have what? AND gate and what? OR gate. Right? We have AND gate and OR gate. Now, AND gate is a series circuit, right? So until the inputs are hot, 1, 1, before you can get what? 1. So that is how I pick it. I have the switching arrangement, the picture of the switching arrangement in here. So anytime I see AND gate, I know automatically, once I see 0, everything coming out is 0. You see the trick?
Yeah, I'm getting it.
That's right. So anytime you see AND gate, you should know that, okay, it's a series circuit. So once there's a break, of course, my light bulb will not come up. So automatically it's 0. Okay, so now we go back to our diagram again, right? And you see, okay, This is it. So we have 1 here and we have 0 here and we have 0 here. Once there's a 0 going through that AND gate, automatically my output is what? 0. That is how I picture the whole thing. You understand?
Yeah.
So this is it. So the next thing is what? OR gate. Now get the OR gate too. If you're able to grab the OR gate with the AND gate, that means you are good. Okay. So let's see the OR gate. See the OR gate. Sorry. Oh, not this is not OR gate. Sorry. Where's my OR gate? See the OR gate. Obviously, OR gate is what? It's a series, but the switch is what? Para. The switch is in para. You see the trick? See the trick? So if any of them is close, once there's 1 inside any of the inputs, okay, automatically you have what? We have an output. Someone is giving us some ring. It seems. If you can mute yourself, let me see if I can mute everyone. Yes, everyone is muted. Thank you. So just have the switching arrangement of this OR gate as well. You see, it's the switch is what? It's in series with the circuit, but the switch itself is what? A para. It's in para. Okay, the A and B is in para. Okay, so the trick is once there's 1, okay, once there's a higher voltage in any of the input, automatically you have what? An output of high. So you put these 2 things in your head that, okay, AND gate is a series circuit. Once we have 0 in there, automatically is what? 0. Okay, I'll come back to OR gate. OR gate is what? A series circuit, but the switching arrangement is what's para. So once I have 1 in any of the input, automatically I have high. So you see the trick, guy. Then we go back to the diagram. Yes,
I'm following.
That's right. Now we go back to the diagram and you see, okay, the first thing over here is what? I have the NOT gate here. Okay, NOT gate is simple. That one I can solve it without even thinking, right? So let's check this one. This is what? SO. Okay, do we know SO? We need to go back and check SO, right? Where is SO? Okay, so this is SO. SO, see SO. SO is supposed to give us what? The opposite, which is supposed to give you 0 and 1 before you can get what? An output of what? 1. If you give you 0, 0, it is 0. If you give you 1, 1, it is 0. So now I have these 3 things in my head. So I see SO. Automatically, if you give 0, 0 to SO, is 0. So I see it there. Okay, this 0 is supplied to what? It's connected to what? A NOT gate. Automatically, I have 1 here, right? So once I have 1 here, see the C. C is having 0. So with the AND gate, we have 0, 1, 0. And you know, once you have 0 in any of the AND gate, automatically you have 0.
Yeah.
You understand?
Yeah, hello.
Yes, I can hear you.
How did you automatically get a 1 at the NOT gate?
That's the function. That's the property. NOT gate receives 0 and give you 1. And it receives 1 and give you 0. So it's an inverse, opposite. Once you give it 1, it gives 0. That's right. Once it sees 2, once it sees 1, it gives you 0. Once it sees 0, it gives you 1. So it's inverse. So that one, you don't need to even think about it. Automatically, you have it at the back of your head that it's an invert. Like it inverts, it just converts the input to the opposite. That's it. So it's clear, right? Good. Yeah. So you only need to put this, you only need to put this 3 in your head. Okay. The AND gate is a series circuit. Once there's a 0, automatically everything is 0. Then you put the OR in your head, the OR gate. OR gate 2, once we have 1 high, then we have higher at the output. So you see the trick. That's how I picked it. So I always have the switching arrangement in my head that, okay, this is it. I always have the switching arrangement in my head. Okay, this is a series circuit. And the brother is what? A series, but it's in para in the switch. And using your eye. So me, anytime I get to the exam hall, if I can forget, I'll just have this. I'll just draw this one quickly on my question paper, and draw this one quickly on my question paper, because every question that comes, whether you combine anything, I'll be able to come out with a solution because I have the switching arrangement. I hope it's clear.
Yeah, the trick is working.
Okay. And you have it at the back of your mind. Okay, the SO there. Once you have 0, 0, it will give you what? 0. Once you have 1, 1, it will give you what? 0. and unless you have 1, 0 or 0, 1 before you can get what? Higher at the output. So if you have these 3 things in your head, no matter how they twist the question, you should be able to solve it.
Thanks a lot. Thanks a lot.
Yeah. Welcome.
Sir, please, the final answer.
Yeah.
I have a problem with it.
Okay. With the final answer, the one we got, this one, right? Is this one? I think he has this. Your internet is bugging, right?
Yeah, that's one, sir. Please, that one.
Okay, so we have a problem with it.
Yeah.
Okay, so let's solve it again. Let's see. Should we start afresh and go through, or where is the confusion coming from?
No, 0, 0 passing through an NAND gate.
Yeah, this is the NAND gate, right? 0, 0 going through NAND gate.
Yeah. Will it give you 1 or 0?
It should be 0. Let's check it now. Let's check AND gate before. Where's the AND gate? Oh, this is AND gate, right?
Yes, please.
So this is the gate. This is a NAND gate, right?
Yes, please.
Wow, 0, 0 is supposed to give you 1. Yes, that's true. Yeah. Because once you have 0, 0 is supposed to give you 1. 0, 0 will give you 1.
Yes, please.
Yes. If this is a NAND gate, 0, 0 is supposed to give you 1. Guys, I hope you are aware of what he's trying to point out. Oh.
Yeah.
Do you understand what he's trying to say? Because look at the diagram. Okay, the switch is in series. It's in parallel with the whole circuit. So once you have 0 here and 0 here, this one will give you 1. Once you have 1 here and you have 1 here, this will give you 0 because there will be a short circuit, what we call short circuit. There will be a short circuit. So there's no way your light bulb will come up. You understand? So 0, 0 is supposed to give you 1. So this diagram, this Y is supposed to be what? 1, not 0, because this is NAND gate. Because this is NAND gate. I hope it's very easy. You do grab what he said. Guys, thank you. The guy who pointed this out. Thank you, man.
Thank you, sir.
So I hope if you're able to grab all these 3 things that I'm saying, the NOT gate, the AND gate, and then the NAND gate, the switching arrangement, I think you should be able to come out with anything. All right. Okay. So if you like to, you can just get a description too. Just chew this one and just go and pour it and just pass. But if you want to understand the whole show and how everything works, then you need to go through the switching arrangement. Okay. It's very, very important. I hope it's cool.
Yes, very cool.
All right. If there's no question, then I think we can end the session, right? If there's a question too, let's tackle that. Let's see.
Excuse me, can you solve like one example of that?
Okay, we should go to the, okay. Which one do you think we should solve? This one? Is this one okay? Or we should go the complex one? Should we do this one?
Complex one, yeah.
Or we should do complex one?
Yeah.
Okay, complex one will be maybe this one, right? This one will be cool, right?
Yeah, right.
Okay, let me download this. And let's see how we can solve this. Okay. Okay, so first thing first, I think A and B, you will solve A and B. A and B is what? Which gate is A and B? Or which logic? I like calling this gate because of my background. Sorry about that. But which logic is this one, the first one?
AND gate.
AND gate.
Okay, so AND gate. And AND gate has what? What is the rule? The rule for AND gate. It's a series circuit, right?
Yeah.
Yeah,
seriously.
That's right. So let's give 0, 0 and see what we will get. Is that the case? 0 here.
Yeah, 0.
0 here. Okay, since it's a series circuit, it will be what? 0, right?
Yeah.
Exactly. Okay. It will go off, then we connect.
It's confused.
You said?
I'm kind of confused.
Okay, where's the confusion coming from? Can we solve it together?
As in the series. 0, 0, A is 0, B is 0, C is
Okay, why is 0, 0 give you 0, right? So we can go back to the table. See this one. The switching arrangement of AND gates. You see, we are saying that this is a series circuit. Okay. So once the switch is open, if this switch is open and this one is open, there wouldn't be any positive charge coming through this bulb. Okay. We will only have negative charge, and we need positive charge and negative charge to light up our bulb. You understand? You understand?
Yes.
Good. So once we have 0, 0, automatically it's what? 0. You understand? So have it at the back of your mind. It's a series circuit. So once the cable is, once I wait wire number there, light number, wire number there, light in there.
Okay.
Do where's the 2? And it will be before I just all connecting now, but so let's go back to the diagram. That's the reason why we have 0 at the back of the AND gate. I hope it's clear, right?
Yes.
Okay. So now that we have, okay. So now we go back to which circuit is this? Which logic is this one?
OR gate.
Okay, good. OR gate. And what is the rule for OR gate?
0, 0 is supposed to be
Once
0.
Once there's a 1, there'll be a no at the out.
Once there's what? Yeah, come again, please.
Once there's one, you get 1.
Thank you. That's the trick.
1 at the output.
That's the trick. I like that. That is the trick. Once there's 1, you get what? 1 at the output. So let's see. Let's see where the OR gate is. See? So once A is closed, automatically there will be positive charge, and negative charge is always there. So our light bulb will come up. The same thing once B is closed and A is open, still we have our light coming up. So you see the trick? So that's the trick. So over here, automatically we have what? Let me write it down. So automatically we have what? We have what? 0. Right?
It's 0.
It's 0, yes. I hope you understand, right? Okay, so now,
yes.
Good. So now we have another gate down here. Which one is this? Which gate is down here? This one.
And
that's what? AND gate, right?
AND gate.
AND gate, good. And we are supplying 0, 0. So of course, this is very cheap because we already know the answer because we've already given you 0 here. So we have 0 here, right? Now the same 0, 0 is going through the same AND gate again. So automatically this place is what? 0, right?
0.
That's right. Now we have 0. We have 0 and 0 connecting to which one? Which gate is this one?
Oh.
Oh, and the trick is what? 1 supposed to be what?
There has to be a 1 to get an output of 1.
Exactly. So now that we have 0, 0.
0.
The answer is 0.
Thank you. Thank you. So let's try and just confuse ourselves by using what? 1 and 0 here. Let's see. It will go off, then we will connect again. I think we have 5 minutes. Can we quickly run through 1, 0? Let's see. Or should we make it 1, 1? 1, 1 or 1, 0? Which one?
Anyone you want.
Okay, so let's do 1, 0. Let's see what will happen. 1, 0 to AND gate will give us what?
It's to give us a 0.
Well, because it's a series what? Circuit. So once there's a cable break or there's a line break, automatically we don't have light. So 0. Right? Okay. So we pass. Okay. So the same value will be coming through this guy. I think we need to, this one we need to put, let's put 1 here. Okay. So this is OR gate. OR gate is receiving 0 and 1. What's the output?
1.
Because
yeah, it has to get a 1 to give an output of 1.
Thank you. Thank you. Thank you. Nice one. So we have another AND gate over here, which is receiving what? 0 coming through this one, and 1 is coming through this one. So automatically we have what? It's a series of 0. That's right. Now we have 1 and 0 going through the same AND gate, of course.
0.
It's a 0. That's right. So it's 0. So we have 0, 0 going through our OR gate. OR gate says what? You need 1 to what? To get what?
To get a 1.
That's right. And
so it's 0, 0.
Okay. All right.
Yeah.
So I think it's very calm. Once you understand the switching arrangement and the principle and the description, once they put the question down, boom, you go back to the description. AND gate says what? Series can say it's a series. OR gate says what? You need 1 to what? Get output of 1. That's it. Once you put that down, you should be able to come out with anything. You should be able to solve any of the logics. I hope it makes sense. The NOT gate you don't need to remember, because once you receive 1, it's 0. Once you receive 0, it's 1. I hope you are cool.
Yes. Sir.
Okay.
That's okay.
All right. All right. So I think we can end the session then. Maybe another time, right?
Yeah.
Yes, sir. You wanted to say something, right?
Oh, I was like, okay, yeah.
Oh, okay, okay. All right. So, guys, my name is William. So, if anything about logics, come to me. If anything about JavaScript, because I'm a JavaScript developer. So, if anything about JavaScript,
JavaScript, you will come.
Yeah. If anything
Oh,
about
boss, we'll come. We'll come.
Yes, please, can you drop your number?
You said?
Please.
Please drop your number.
Can you drop your contact?
Okay, I can drop my contact, but let me give you my channel, my JavaScript channel, YouTube. Where is this guy? Let me see if I can get you my channel. When you go to YouTube, just type Jet Coding. Okay, that will be my Jet Coding. Okay. Oh, coding 1. See. Yeah, so this is it. Jet Coding. And we started a series of some algorithm, basic algorithm of JavaScript. You can just go over there and just have fun. All right.
All right.
All right.
Are we going to have this meeting again, or this is the only meeting?
I can't hear you. You said?
I'm asking whether this is the only meeting or you will be meeting again.
Oh, anytime you're ready. I think I'm free on Sundays around the same time. So anytime you need anything related to logics and JavaScript, I'll be here for you. Okay, no problem. Just contact Mohammed. Mohammed have my number, and I think he knows me. So if anything, just go through him and you get to me. Okay.
Right, sir.
All right. Okay. So, guys, nice meeting you guys, and we will meet again. All right.
Thank you very much.
You're welcome. You're welcome.
All right, Mr. William.
Okay. Until
Thank you so much.
Martin, until there be another friend. Why?
Martin,